Hi friends, I just want to start out this recording by telling you that this was a pretty rough recording. This is the first time I gave this workshop. And I spent quite a bit of time talking with the people who were at the workshop about like feedback and stuff. And so I didn't spend a whole lot of time editing this, and so you might get some of that. And so I apologize for that. If you want to see like a high quality version of this workshop, that's definitely going to be much better than what you see here, much improved based on the feedback that I got. Then please feel free to subscribe to Front End Masters where I'm giving this workshop, and it's going to be awesome. Yeah, the exercises and everything in this workshop and the demos and whatnot will probably teach you a lot about ASTs, but the Front End Masters workshop is going to be like stellar. So anyway, I hope you enjoy this, and I'll see y'all later. Okay, so we're going to be talking about transforming and linting code and using abstract syntax trees in JavaScript. So really great stuff. A bunch of stuff about me on here. This workshop is actually, I prepared it for Front-End Masters. All of these things except for Front-End Masters looks like it's linked, so I still need to link Front-End Masters. But anyway, so if you care to look into any of these things, feel free. But my slides are right here. Whoops. AST Workshop slides. So if you want to pull those up and click on links and stuff, you can later. Okay, before we get started, let's stand up. It's going to be kind of weird with just three of us, but it's still good. I don't do it because it's fun. I do it because it's good. Okay, arms out in front of you and squat down. This is air squat. We'll do 12 of these together. Okay, and count out loud. Ready? 1, 2. This is a big crowd. 3, 4, 5, 6, 7, 8. Do this at home too. 9, 10, 9. Just kidding. 11, 12. Okay, awesome. And shake the person next to you's hand and thank them for coming. So, all right, cool. Yes, that is so good. I'm so glad that we did that. Okay, great. So let's just get some context here. What this workshop, this is why I do practices. Workshop, what is this workshop all about? So I'm going to give you an introduction to abstract syntax trees. I actually have a talk that I'm just going to give you that introduction. And I'm also going to give you an introduction to inspecting and traversing ASTs with ESLint and Babel. So yeah, this traversing should probably be manipulating because we won't actually traverse it ourselves. That's why we use these tools. So yeah, that's cool. I'm not going to give like a super deep dive into ASTs. It's a really big topic. You're not going to learn about every single node type there is or anything. But you'll learn enough to learn all of that. And like what I found with using these tools and learning about ASTs is the only way to really learn it is to just do it a lot. And so we'll be doing that a lot. And we're not actually going to publish packages. I'm not actually going to set up a special repo for creating an ESLint plugin or a Babel plugin or something. I figure those are things that you can learn really easily on your own time. And so focusing more on the actual writing of the plugins. And we will be testing the plugins. That's how we'll verify that your plugins are working and stuff. So you'll learn how that, at least with ESLint, there's a very defined way to write tests. We'll use that. With Babel, there's sort of a defined way to write tests, but it's not really well defined. So we'll be doing it in one way, and yeah, it's good. Okay, so this is how you get things set up. If you haven't done this already, this last one, where you're running that node script, you'll want to set up your own email. Basically what this is doing is, I'll explain it in a little bit actually. So logistics, what just happened? I just opened the photo booth app. Oh my goodness. Okay. So this is the way things are going to work today. For each topic, so we're talking about ESLint plugins, Babel plugins, and code modding your code with a Babel plugin. And so and each one of these has like 2 demos and 2 exercises. ESLint actually has 4 demos and 4 exercises. So for each one, we'll do a demo, and then we'll do an exercise that's similar to that. So I'll just run through the demo. You can ask questions, whatever, and then I'll set you loose on an exercise. And then the last thing, so your exercise is basically make these tests pass with your plugin. And actually, I think the first exercise of some of them is also write tests for this plugin, so you can have that side of the experience too. But the last test for every exercise is, did you submit your elaboration and feedback? And so there is, we'll just look at an example here really quick in your exercises. Here. There is this link right here. And that node script that I had you run with your email address actually goes through and updates all of this with the email that you added. So family.us. And what that does is this will forward to a Google form with some answers pre-filled in. So the workshop, the exercise, and your email address. And then you just have to fill in these couple of things. So this elaboration piece is really a valuable piece of your learning experience. This is actually part of the workshop. It helps you retain what we've talked about, what you've learned. So don't skip this part. And then this is really helpful for me in making these exercises better. So great. And so if you don't want to run that node script or it didn't work or anything, don't worry, because even if all you have is this, it'll still work. You'll just have to fill in your own email yourself every time. But once you've done that, then you just change this to true, and your test should all be passing. So that should be great. Cool. So then if you finish early, feel free to help others or even make pull requests to improve things, like if you finish way early or something. Yeah, and then for how we communicate, if you have relevant questions or something that you feel like would be useful for people to know about or something, feel free to raise your hand. I am going to have the chat open, which actually doesn't exist yet. Whoops. This is why we do practices. I'm going to create it right now. Don't send me a PR. I already have it. Okay. So yeah, I'll have the chat open. So if you want to chat with me there, then like if you'd rather, or if you're watching online, it's like the only way you can communicate. Hello, Ryan. Thanks for standing up. Oh, how many people we got? 10. Sweet. Hi, everyone. So yeah, if you would rather just chat it to me, that's fine. You can also do one-on-one chat if you don't want the world to see your chats. And pretty much only do like relevant to the workshop questions. If you have things that are not relevant to the workshop, you're just curious about something, you can ask me at my AMA. Definitely fill out the surveys, and feel free to follow me on Twitter because I tweet about stuff sometimes. Okay, great. So, yeah, that's the logistics. Any questions about things? Okay, cool. So let's get started. So like I said, I have a talk about ASTs. I'm going to give... Hey! Welcome. We are welcoming a third member of our group. This is great. You just missed all the intro stuff, but that's...
Yeah, I just saw your message.
I'm glad that you came. Yeah, I'm glad you came. So I'll give you a quick rundown. We're talking about ASTs, talking about some of the using tools to manipulate and inspect them. I'm not going to actually publish any plugins or anything, or even make like a repo demonstration. I figure you can figure out how to do that. We're mostly just going to focus on using the tools. This is how you set it up. So I'll actually paste this into the chat right now. And actually, well, I don't have Slack open, but you can just look at that. Oh, okay, cool. So yeah, there's the setup there, and yeah, I just went over the logistics, but basically it's like we'll do, I'll give a demo of a certain thing, and then you'll do an exercise that's similar to the demo. And then there's an elaboration and feedback form that's really important you fill out. There's like a comment in each exercise for you to follow a link to fill that out. And then, yeah, raise hand and stuff. Okay, sweet. that was the same thing we just did, except really fast. Okay, cool. So yeah, like I said, I'm going to give you my talk, like a quicker version of the talk, Beginner's Guide to ASTs. And it's quicker because we're going to go more in depth later. So yeah, this will just give you kind of an overview of what ASTs are and why you should even care. So why should you care about ASTs? ASTs are what enable ESLint. Actually, quick question, how many people are already familiar with ASTs? Okay, relatively. Okay, cool. So ASTs, abstract syntax trees, are what enable Babel to transpile future code to current code. And it also enables a lot of other really cool things, like this Babel plugin Lodash thing. So this code right here, this is a pleasure, or this is not a pleasure to write, but it's a pleasure to use because you're cherry picking the specific functions from Lodash that you need and not just bringing in the entire Lodash module, right? And so you're saving a lot on bytes and JavaScript parsing and stuff. It'll be much faster. But it's not a pleasure to write because every single method you want, you have to add another import, and it's no fun. So this plugin lets you write your code just the way that you would want to, with like you can do import specifiers, or you can just import the whole thing, and then it'll transpile it to this version. And so one thing that I found with Babel is that it basically, like, I'm pretty sure that the whole purpose of Babel is to enhance the developer experience without sacrificing the user experience, or sometimes even to just enhance the user experience in ways. So like even the Babel minifier, which is currently called Bebely, which I think they're renaming to Babel Minify finally, but that's one situation where it doesn't actually enhance the developer experience, but it like hugely enhances the user experience. And so yeah, Babel just makes it so you can deliver great experience to users without sacrificing your own experience as a developer. So that's one example. Another really cool example is like I have lots of examples where I'm doing or code where I'm doing a lot of dot dot slash dot dot slash. Like I've got even more dot dot slashes, and it's a real pain. Anytime you move files, you have to go update everything. So I don't really use this plugin for a lot of stuff. Like I don't want to alias everything, but there are some things like utils that I want to have accessible throughout my whole application, and I don't want to have to worry about when I move files around and stuff to update the relative path. So this plugin basically allows you to provide an alias. You can call it whatever you want, and it'll update your import statement to reference like the correct path, the relative path. So that's super cool. One of the I saw a tweet just the other day about like this pattern specifically, or at least the utils folder. I think it was Andres Staltz who said, instead of naming it utils, name it to be published or something like that, like things that you can eventually publish to the registry. And I actually like that idea because one of the cool things about node modules in your application is just say import Lodash from Lodash. You don't have to do relative paths or whatever. And this basically gives it that same kind of experience. So anyway, just kind of a tangent on this awesome plugin. But yeah, that's a cool one. Again, enhancing the developer experience without impacting the user experience at all. And then this one's really useful if you're not using this in your React applications. Maybe you should. But it basically takes your prop types and it removes them, all your prop types definitions. So you do this for production mode because prop types is disabled in production anyway. So why are you shipping those bytes for actually like creating those prop types? I should probably update this slide because it's no longer on the React one. But yeah, prop types, fun stuff. Okay, so that's the Babel plugin side of things. Really cool stuff. ESLint side of things is also awesome. What I love about ESLint is JavaScript is very much a like let's break your stuff when you run your code. But ESLint and Babel actually allow you to like fail fast and fail early. And so this ESLint plugin import is one of my favorites. I love it because if I do get that relative path wrong, then it's going to tell me, hey, I can't find a module called like at that path, so maybe you got the path wrong or something. And so yeah, that one's super helpful. It has a ton of stuff too. Like it'll say, hey, you're importing a name specifier, but there's no export in that module, so maybe you have a typo there or something. So really, really cool, reaching across dependencies. There are a bunch of others that I should probably list in here as well, but yeah, like there's another one of my favorites is the accessibility plugin for React or for JSX. So it'll tell you, hey, you have a link, but there's or an image, but there's no alt text for this image. That's accessibility fail there, and so make sure that your stuff is accessible as possible. And then code mods. So like if we were to say, hey, that Lodash plugin thing is cool, but I don't actually want to use it. I want all my imports to be cherry picked like just in the source, and I want to write my code that way. You could actually take that Babel plugin and apply it to your source code and output your source code with that, with the results of that plugin. And that would be basically a code mod. So it's much better than like a regex find and replace. Good luck with that. And we're going to be writing one of those today as well. So code mods are awesome. Or another example is you're migrating from Ava to Jest. There are code mods written that will automatically change your code to migrate your test base to that new framework. So that's awesome. Yeah, code mods are an amazing thing. Or like React 15 just deprecated prop types and create class, and now those things are in separate packages. And so they released code mods that you run across your code base, and it'll update your imports and update like everything to magically use the new API. So awesome. Good luck doing that without ASTs. Like on a side note, the tools that most code mods are using, or the tool that most code mods are using, is called JS CodeShift, and that's a great tool. It tries to emulate the like a jQuery like API where you find this thing and then you do this thing to it, and then you replace it with this other thing. I have tried like 6 times to use this tool and found it to be really difficult. At least for me, it just doesn't work with the way I think about ASTs. And so there's now a tool that you can point to a Babel plugin and run that across your code, and that will be your code mod. So you can use a Babel plugin to code mod your code. And I like that much better, and that's what we'll be doing today. So you just learn one API, and in fact, the ESLint and Babel APIs are really similar. So you learn, it's called the visitor pattern. We'll talk about that later, but you learn the visitor pattern, and then you can have all the power in the world, and it's great. Okay, so let's look at what an AST even is. So actually, sorry, before we do so, does anybody have any questions about all the things? Okay, why ASTs are awesome?
I actually have one.
Yeah.
Yeah. So the one with the ESLint, this one?
Yeah.
So are you like integrated with the?
Yeah. Yeah, this is Atom, and it's using the ESLint plugin. Yep, it's great. But yeah, there's also like the CLI you can run, and it'll output stuff in your terminal and stuff. Okay, cool. So code is for humans, and we write all of this code with variable names and stuff just because it's useful for us to read. The computer doesn't care anything about this. Like this variable could be anything. It doesn't matter. It just needs to be correct syntax. But we write it for ourselves so that we can read it and maintain it. But when the computer gets it, it turns it into something called an AST. And this is an example of what that code looks like using the Esprit parser. And so you got a file and a program, and that has a body, and that body has a variable declaration and declarator. And like this thing's enormous. It's a JSON object that represents your code. So yeah, pretty wild stuff. Not very fun to like parse through yourself. And so we have this really awesome tool from Joint.js. And this actually, this tool actually only exists for Joint.js to demonstrate their cool little graph thing that we're going to be using. It's not actually meant to demonstrate ASTs, but we're going to use it for that anyway. So, yeah, so we have this code. Let's bump this up a little bit. Var A equals 42, B is 5, add A, and then var C and stuff. Pretty neat. But it creates, the AST can be represented in a tree. It's an abstract syntax tree. And the root of your tree is your program. It contains all, everything for the program, for the file. And that this is called node. Each one of these boxes is actually called a node, and this arrow represents some kind of relationship that this node has to these others, normally like a parent-child type of relationship. So in this case, the program has a body, and that body is an array of these other nodes. And then we have a variable declaration here, and that variable declaration is represented by this code, var A equals 42. And a variable declaration can have a variable declarator, and that's the A equals 42 bit. And the reason for that is because you can actually have multiple variable declarators per variable declaration. So you have one here, one here. And so that's why those are kind of split up like that. So this variable declaration is of type var, and it has two declarators as part of it, A equals 42 and X equals 42. And then variable declarator is a node that has a left and a right. And in our case, that's the identifier on the left and a literal on the right. But we can actually, let's go ahead and change that literal here really quick to be, here, we'll assign X to be A plus 1. So same result, but different code. So now this X variable declarator still has the identifier on the left side of X, but now on the right side it's a binary expression node, and the binary expression has a left and a right, where the left is an identifier and the right is a literal. And we can go on forever and ever and ever, plus 2, plus 3, plus 4, times 4. And now things are looking kind of crazy. Yeah, don't write code like this, it's weird. But we have binary expression, and on the left can be another binary expression, and on the left is another and another, until finally you reach an identifier and a literal. Yeah?
Are these names like variable? Is this like an extender, or is it?
Yeah, that is a great question. So there's an effort to standardize on this because there are lots of different parsers in the world. And this is, I believe this is the effort is inside the ES3 spec. So, yeah.
Different parsers.
Yeah, yep. And that will probably always be the case, that they generate slightly different trees. This is why like Babel ESLint exists as a parser for ESLint, because what it does is it parses the code using Babelon, which is Babel's parser, and then it takes the AST and transforms it so that it conforms to ESLint's standard. And so hopefully that will, over time, become less of an issue. But yeah, for right now, you have to have like these things that make these ASTs conform to each other. I just realized that I don't have my laptop plugged in. Do that really quick, because we're going to be here for longer than 37 minutes. Okay, neato. Good question, yeah.
So is the reason they call it a variable declarator because you could have potentially more than one variable declarator? Or
correct.
Is it, okay.
So you have the declaration that can have multiple declarators.
Oh.
Yep. And that's the case here. We have A equals 42 and then X equals this giant expression.
Oh, I see. It's cut off. So I thought they were both declared.
Yeah. Sorry, this charting library is pretty cool, but it's not that cool, I guess. Okay, great. So I'm like we can also go down here and look at this function. There's a function declaration. Function declarations have block statements, and that block statement can have multiple statements in them. This one only has one, but there could be many. and so on and so forth. So hopefully this idea of your code being a tree, or your code being something that can be represented by a tree, it can feel pretty straightforward. And one of the things that I love about ASTs is the more I learn about ASTs, the better I understand my code, because I can see, oh, okay, so because the binary expression ultimately leads me to a plus 1 is being on the left side, I can see very clearly that this is the first thing that's evaluated. Like, this is a unit, and then this unit is part of this binary expression, and so on and so forth. So you learn more and more about your code the more that you...
Fair to say you start at the lowest level of it?
Well, it really kind of depends, right? Because we could also do something like wrapping things in parentheses and potentially totally change the tree. This is actually one thing that I love about Prettier is Prettier, the source formatting tool, because it will actually add parentheses in for you in some cases so that it'll illustrate to you what precedence is going on. So it will take the precedence that exists and make that precedence explicit. So anyway, just kind of an aside thing. If you haven't looked into Prettier, you'll see Prettier in action when I'm coding for you, because when I hit save, it'll auto-format it, and it's like magic, and I love it. Okay, great. These are great questions. Any other questions? So this is a cool tool to hang out in and play around with, but it's a little bit limiting, and there is a better tool that we're going to look at here in just a sec, and that is AST Explorer. This thing is so cool. It is so amazing, and it has. I am 99% sure that like 99% of the Babel plugins and ESLint plugins were written starting in AST Explorer, because you just can't do it without AST Explorer. So this is what this is. We have, and if you want to go check it out, it's astexplorer.net. I'll actually copy this full gist and put it into the chat, or this full URL, so you can look at this code. But basically what we have on the left side is our code, and what we have on the right side is representation of our code in a tree format. We can also look at it in JSON, and nobody wants to do that, so we'll go back to the tree view. And we can navigate around it. So we have this program, and we see on the left side it's highlighting as I change what I'm hovering over on the right side. We have this variable declaration. It has a declarator, and it has an identifier as like the ID property, and a call expression as the init property of this variable declarator. And then that call expression has a callee, being the identifier of require, and it has arguments being a string literal of unique random array. So like, it's a really great way to kind of explore your code. And also what's cool is as I navigate through my code, it actually will autofocus on the node that I'm clicking on. So that's pretty awesome. So I often say that if you see some code that you're not familiar with, like you see this like this destructuring looking like syntax up here, then you can just paste it into AST Explorer and look at, oh, that's called an import specifier. And now you can go look up what an import specifier is, because it's really hard to Google syntax, but it's not so hard to Google names of things. So yeah. So I should actually, as part of an intro to AST Explorer, I should show that it will parse, or it has parsers for tons of things, CSS, GraphQL, even like SQL and stuff, pretty awesome. And then for each one of those, they have parsers. Some of them only have one, but here we have like a bunch of parsers for JavaScript, Babylon 6, and you can like have some settings and stuff. And then beyond that, you can actually transform right in the browser. So if we say transform with Babel version 6, then it'll actually create a like just a demo transformer for you, and it's just changing all my identifiers to be swapped left to right, right to left. So pretty wild stuff. And we'll look we'll be spending quite a bit of time in this tool, and we'll be exploring this a little bit more. So, but that's AST Explorer. Anybody have questions about that? Here, let me bump that up a little bit. Yeah, yeah, we'll be using console log plenty in this though. Yeah, but this is pretty wild. Like you'll never do a regex find and replace on a big code base ever again. Just write a Babel plugin for it. Okay, so how do we use these tools to manipulate and inspect ASTs? So we'll start with the ESLint plugin. And I'm not, so like I could like code it all up for you right now, but we've got demos for that. So I'm just going to show you what it looks like, and then we'll get into the demos. So this is still more introductory stuff. So here I have the parser set to Esprit, and then the transform is set to ESLint v2 because I made this a while ago. So let's, here actually let's do this. Switch it to ESLint v3. My plugin still works, great. No breaking changes for me. And I'll just save this. Save. Okay, so here's what we've got. We have some code up here that we want to lint against. So you basically, like when you're developing an ESLint plugin, you'll say, okay, I'm going to put a bunch of code examples of things that are good and things that I want to lint against. And then down here, I'll put in my ESLint plugin, and then over here, I'll see that ESLint plugin firing off. And so if it fires off on code that's good, then you still have work to do, and so on. So for our particular case, this plugin actually already exists. And that's actually one of the challenges for all the examples and demos that I have for you, is if it's really a practical thing that you could start using today, then I would just open source it, and then you wouldn't need to write it. So some of these things aren't entirely practical or already exist. But we'll talk about that more later. So for our case, this is bad code that we want to lint against, because we want to say every if statement should have a block, because otherwise, if you write your code like this, you could say console log blah or bah, and you might be fooled into thinking that this will only log if this condition is true, but that's not the case. You have to have curly braces because white space doesn't matter in JavaScript. So yeah, we're going to say that this code is no good, and we'll lint against this this pattern. This code is fine because it does have a block. So the way that you do this with ESLint is you export an object, and that object has some metadata that you can provide if you so desire. You don't have to, but it's good for like generating docs and stuff like that. But one thing that you absolutely have to have is this fixable, and we'll talk about that later. But if you want to add a fixer, you need to have fixable. So yeah, and then you have this create function, and that create function accepts this thing called context. And you can look up the documentation for all of the things you can do with context, but basically it allows you to manipulate things or to get the source code for things. One thing that you learn pretty quickly with ESLint is that it operates on, at least the fixer operates on source strings rather than ASTs when you're actually like manipulating the AST. Yeah, sometimes it can be really useful to get the actual source code for a node, so you can lint against certain patterns or styles or something like that. But yeah, context gives you a bunch of useful contextual methods for nodes. But then the object that you return from this create method is what's called a visitor. And we're going to spend a lot of time with the visitor pattern. So actually, could you close that door real quick? I get distracted easily or something, I guess. 13 people hanging on. So, hi, people. I do have the chat open, so if you want to go check that out. Okay, cool. So if statement here is a node type, and that is a property on our visitor object. And so the visitor pattern basically allows you to not have to worry about how this tree is getting traversed. So I actually, as an exercise, tried to write my own AST traversal, or my that exposed a visitor pattern API, and it's not an easy thing to do, because let's say that you want to find all of the identifiers. So what you have to do is you get an object, you start with the program, and then you go down to the program has a body, and that body could have nodes inside of it, so you want to dive deep into the body. Here, let's turn off this autofocus thing. And then the body has properties inside of it, and so you'll iterate through all of the nodes inside of the body. And then these nodes themselves, based on their type, can also have nodes, and you keep on going all the way until you find a node that's of type identifier. You have to do a lot of iterating and stuff. It's not really an easy thing. And so what ESLint and Babel do is they implement what's called the visitor pattern, where they take care of traversing. They go through all the nodes, and based on the type, it'll go into the left property, or it'll go into the test property and find the nodes. And whenever it comes across a node that you have a visitor for, it's going to call your function with that node. So in our case, we have an if statement, and so it'll call our if statement function with the node, and then we can inspect that node at that place. In the ESLint case, we inspect it to make sure that this if statement has a block. In Babel's case, you inspect it to make sure that this is actually a require statement for the module that you're trying to write a Babel plugin for, or an import statement. So it's a really common case to start at the very top and say, is this the type of node that I'm looking for? So you say, is this node the kind of node I'm looking for? Because it is the type, it's going to call with the type. So in any case, we have this if statement. It's going to call our if statement visitor with the node, and then we're going to look at that node and determine if it is a block, if the consequent is a block and the alternate is a block. So in our case, we have this if statement. It has a test property. That's a binary expression. We don't care what the test is for our rule, but we do care that the consequent and the alternate are blocks if they exist. So our isBlock function is fairly straightforward. It takes a node, and if the node doesn't exist, then we don't care. It's fine. If it does, then we want it to be a block statement. In this case, the consequent is an expression statement, so we don't have a block on this consequent, and so we're going to this if statement will fail. We won't return, and we'll report it. We use the context to report on that node with this message, and we can talk about the fix function a little bit later. But any questions about that so far? I just talked to you about the visitor pattern and inspecting the nodes and stuff, so there should be questions.
Yeah. So when you return the object, you say if statement. So I'm assuming it's binary.
Yes.
Whatever.
Yep. Anything.
What does it do to report?
Yeah. So this context.report is an ESLint specific thing, and with ESLint, the goal is to find code that's wrong, and so you report the wrong code. And in our case, we say if the node consequent and the node alternate are both blocks, then we're fine. We'll just leave. This isn't the type of node that we're looking to report. But if one of them is not a block, then we want to report this.
When you say reporting, editing the comment?
Yeah. So with ESLint, we just say, hey, ESLint, this rule has been broken, and you do with that what you will. And ESLint, based off of the way it's been configured, will will result in an error, or it will result in a warning, or however it's been configured. But all you concern yourself with is find violations of this pattern that I'm trying to lint against. And it's also not just about code style. There are a lot of rules about code style, but we're going to be writing some rules about using deprecated APIs. We don't want to do that, or using an API in a way that's going to be really slow, or something like that. Yeah.
So if you wanted to, so this if statement thing, basically it's going through every single if statement will get called on that, right? With the correct node.
Yeah.
So if you wanted to do something crazy, like let's say if you have an if statement, you have to for some reason have another if statement inside.
Sure. Yeah.
Then does that mean that you would do this if statement block, and then inside of it you would have another if statement block?
Yeah. Good question.
Select on.
So like if you wanted to enforce this pattern, like if true, and then inside of here you also want to have if false, whatever the condition. We don't care the condition.
Mm-hmm.
Just every if statement should be either nested or have another if statement inside of it. Okay, so the way that you start out with writing a rule like this is you first look at the AST tree itself, and you see, okay, what about this pattern is unique? What do I want to ensure? And in this case, it's an if statement that has a consequent, which has a body that has an if statement, right? Because the consequent is a block statement. Okay, so as far as like actually writing that, instead of, you asked a great question, and that was, okay, so do we return another visitor here with an if statement, right?
Mm-hmm.
So that's actually not what you do. You only have one visitor. But if we log the node, and let's pull this open, and our second to last if statement is going to be the one we're looking for. Inside of here, we can actually inspect this node, and we have a consequent with a body. That first item is an if statement. And so we'll get the node, and we say, hey, does that node have a consequent with a body with the first item being an if statement? If it doesn't, then that's a violation of this rule. And so at a certain point, you do have to sort of traverse the tree yourself. However, if it's a really if it's a simple traversal like this, it's not all that bad. But if it's a pretty complicated traversal, then with Babel, I know that you can traverse again. You say, hey, traverse on this node. And I'm pretty sure you can do that with the ESLint. If you can't do that with the ESLint, then you can actually just import Babylon into your ESLint rule and just traverse it with Babylon, which actually isn't a terrible idea because Babylon, especially with like a fixer function, if you wanted to manipulate an AST, I'm sure you could figure out a way to do that. Pretty wild stuff, but yeah.
So the concept of the algorithm, are these like if statement node property?
Yeah. Yep, that's a great question. So, and I believe that is in the ES tree specification. I've never actually looked into this spec.
Okay.
I find it, well, yeah.
Yeah, so the challenge, I was wondering, the problem that I see, the hard part, is basically like trying to figure out all the possible combinations that's going to apply to the root. Is there an abstraction for
Not really. They're like
this thing that you do in your Explorer? You're just like, okay, if I have a ternary inside of it's like it's hard to think of all.
yeah. Coming up with all the cases that of how people could write code that could violate your rule, or like if you're writing a code mod or something. Okay, how are people using prop types? I need to make sure that I cover all of those cases so I remove them properly, or something, or I don't remove prop types when they actually are required for production for some weird reason. Yeah, so it's not easy, and there's not really an abstraction for that. Basically, the solution is to just come up with tons of test cases.
The process is like Explorer, you find patterns with the AST and you write it.
Yep, it's pretty much explore, find patterns, and write your rules. Yeah.
So this actually, that question made me think of something else, and that is usually in projects like you showed, there are all these useful Babel plugins. So there are a bunch of different ones that you can include at any given point in time. So one question that I had was, I remember reading about presets versus plugins, and how one of them, the order kind of matters and the other one kind of doesn't. And so how, I know the idea of the AST is that it boils everything down to this, this single source of truth that you can actually use to do these manipulations. But at what point does it become weird where you have like 7 or 8 different plugins that are all transforming the code in different ways? How do they prevent, or can it be prevented, like worrying about the order or worrying about something screwing up your plugin and vice versa?
Yeah, so
Especially
that
if
is
it's
actually
really
that is a big problem. I have a massive plugin that I'm in the process of writing right now where like it's actually I have a plugin and then I have another plugin that I need to run and then like another set of plugins that I need to run. And I can't have them all run on a single run of the AST. I actually have to say, okay, run my plugin, and then once you're finished with that, now run the second one, and now run this other set. Because there are some cases where like my plugin messes up the AST in a way that this other plugin can't. And so like there you could because the way that, at least on Babel side of things, the way that it works is it runs through like it takes your array of plugins and it traverses the tree, and anytime any of those plugins needs that node, it's going to give it to it, and then it can make any change. And so the order actually does or can matter, and it can blow up in any order potentially. And so yeah, it can be a little bit complicated. Most of the time, like for most use cases where it's like use Babel preset env, and that just has this set of plugins for your environment. Most of the time, those plugins won't mess with each other. Like object spread plugin isn't going to have a problem with arrow function plugin or something like that. But sometimes they can cause problems. So I know that the Babel team is actually right now working on a way to make it a little bit more straightforward. But yeah, it can be a challenge. With ESLint, one funny thing, because ESLint does actually allow you to manipulate the tree, and that's with this fixer function. And so what they do is they'll run all of your plugins, and if any of them fixed any code, they'll run them all again. And if they fix any other plugins fix code, then it'll run it all again, up to 10 times. And if it runs 10 times, then it's like, okay, yeah, you're all messed up. But yeah, that's the way that it works. It actually works like extremely well, because you'll see in our examples, like if we wanted to fix this code, then the proper way to fix it, like according to our code style that we have here, is to add these curly braces plus this extra white space and a new line, and then a new line and another curly brace, right? But should we really concern our plugin with your code style? Like in particular, like what white space? Should I use tabs or spaces? So what you do instead is you just fix it like to the minimal amount that you need to, and then you let other plugins deal with the code format.
So is this why when I set in the regular ESLint option where it says auto fix on save, I have to do save every time I hit save, it will do one step into it, so I have to hit save like 5 times sometimes.
Oh, really?
For it to actually, because every time I do it, it's like, oh, okay, puts it on a new line, and the second time it does the indentation. Third time it will like transform the if block.
What editor do you use?
I use Visual Studio Code.
Oh.
Yeah.
I blame VS Code.
Maybe.
No, it's VS Code is a little less mature than Atom, so I expect that's something that you could help them fix. But yeah, that's kind of odd. I'm guessing that maybe they're only running ESLint once somehow, which is weird because ESLint does this thing by itself. So I don't know how they would even do that. But yeah, that could be potentially why. Any other questions? Okay, sweet. ASTs are so fun. So this fixer function, I'll actually we'll talk about that during the demo. But basically, it allows you to automatically fix the code for things like style. Things are normally fairly straightforward to fix. But if you get too much more complicated than style, then it starts to get a little unwieldy, because your fixer utility that you're given actually operates using strings. And so you say, hey, replace this node with this string, or replace this range with this string. Yeah, it's a little bit less powerful, whereas with Babel, you say replace this node with this other node, or append another node here, or something like that. So I've actually played around with the idea of maybe using Babel to write my fixer and then just returning the string that I want it to replace with, just like creating the AST with Babel that I want, and then converting that to a string and then saying, hey, ESLint convert or replace this with this string. It's kind of interesting. Okay, cool. So that's the ESLint side of things. Pretty cool stuff. Again, the basic idea is define your visitor. Which nodes do I want? And then, like normally at the top of your visitor, you say, is this node does this node look like the type of thing I want to report on? Or sorry, is this node good? If it is, then we just return. Otherwise, report on it. And sometimes like the same, you'll have like several conditions, and you could have several reports in a single rule. That and you can also have like really nice and custom messages that say, hey, you're doing this pattern, but it should look like this or something like that. So pretty cool stuff. Okay, cool. On the Babel plugin side of things, again, we're still using AST Explorer. We still have this AST, except this time we're using Babel 6, and we're transforming with Babel version 6. So the AST will look slightly different. Actually, here we'll pull it up just so you can see, get kind of an idea. So here with Babel, you start with a file that has a program, and with Esprit, you start with a program. And then there are a couple slight differences as well in these two. So just kind of.
Actually,
Yeah, sure.
Okay. Might be related to but basically, there's all ES6, ES7, right?
Yeah.
When you're writing your rules, how do you know where you start? Should I care about async?
Yeah.
Or not?
So it kind of depends, but like with Babel and ESLint, well, sorry, with let me take a step back. So with ESLint, you configure ESLint to what kind of code you want to allow. So here with the Spree parser, you actually can specify the ECMA version, specify source type, and whether you want to have a bunch of other things. With Babylon, it kind of depends on what plugins are included, and so there's like syntax plugins for async await and stuff like that. Although I believe that Babel can parse any kind of code through Babylon, any kind of standard, even if it's not quite standard yet, like stage 0 things even, maybe, some things. And so like regardless of how you configure it, it can parse those things, but whether it actually transpiles those is based on the plugins you include. And so as far as whether you need to worry about it when you're writing a plugin, you normally won't need to worry about that. If, for example, you're writing a plugin that says, all my functions must return a string literal for some weird reason, then in that case, you'd want to make sure that it's not an async function, because in that case, it's actually going to return a promise that resolves a string literal. You will want to concern yourself in some ways with some of those like newer features and things. But most of the time, you only really need to worry about that if you need to worry about that, I guess. Does that make sense? Okay, yeah.
Oh, sorry. Just going off of this question, like, I actually had a similar thing, and that is, if you were to, say, implement something like a new spec just came out for ES6, or you're even writing a new part of the new spec or a proposal, and you want to demonstrate that, this is how it would look like in a real application. And so you want to actually so you would have to create a parser first that would then give Babylon the correct selector to use for that in the visitor pattern. Is that how it works? So that's a separate thing.
So if you wanted to add syntax, unfortunately, like a pluggable parser is a really hard problem, and so there's no way to really add plugins to any of these parsers as far as I'm aware. So what you have to do is you fork a parser, so you fork Babylon, and you add all the magic code stuff I've never even looked at or done to make it so it can parse your new code. I'm pretty sure that involves like fancy regex and stuff. Pretty wild things. But actually, if you're interested in that, there's it's called Super Tiny Compiler from the James Kyle. This guy, amazing person. It's a compiler written in JavaScript, and I think it has more lines of comments than it has lines of code. So it's really, really well documented how it works, and you could go and inspect what it's doing. So this is actually fantastic. He gave a talk, which I'm sure is linked here somewhere. Talk? No. Just look up. He gave it at EmberConf. super tiny compiler ember conf. Yeah, how to build a compiler. It is a great talk. Definitely recommended.
He got me at the super ironic title there. Super tiny compiler.
Yeah, it's a huge title.
Like
Yeah, yeah, he's great. Yeah.
Do you have a
To join the
link?
live stream. Yeah, I am recording the live stream. You can get Twitch TV. Can't see dots. Here, I'll put that in the Gitter chat. Sweet. Oh, and it autoplays. Nice. Paused. Okay, great. So on the Babel side of things, like I said, the AST is slightly different because we're using Babel on 6. But yeah, what this plugin is doing is probably a premature optimization. But have you ever like written regex and thought, like, I really like having this regex right here, but I don't want to create this regex every time this function is called. Like, I could just hoist this to the top of the module, and then it's not being created. I'm pretty sure that, at least for regex, JS engines will probably do this automatically just behind the scenes because they can see very clearly that's a literal, I can fix that. But it's kind of fun to illustrate this. So what this plugin is going to do is it'll find all regex literals and hoist them to the top of the module so that it's not recreated every single time you call this function, which it might not actually be doing. But yeah. Okay, so a couple of differences here. Babel plugins are automatically transpiled, so you can use ES modules or ES6 or whatever. So here we're exporting as a default our function. And this function is basically like the create function, where it returns, well, sort of like the create function. It returns an object that has a visitor property on it. And that visitor property has the nodes that you want to visit. So a couple slight differences there. You can give your thing a name, and I'm sure there are a couple other metadata properties you can give it here. But yeah, one other thing is this function, similar to ESLint receiving the context, this function, and that context has a bunch of utilities for you. This function receives Babel, and this Babel is actually the same as Babel core. Oops, require Babel core. So you just get Babel core as an argument to your function. Babel core has a bunch of things. One really common thing that you'll need to get is types. And so it's pretty common in Babel plugins to alias that to T. And then you use that to create new nodes or to determine whether nodes are of a certain type or whatever. In fact, here, let's console log T here, see what it is. It's this object that has a ton of stuff on it. Like assert object property. So you can assert that a node is of a specific type, and if it's not, it'll throw an error. Or is export specifier. So you can assert this, or you can say if is export specifier node, then do this thing. Yeah, lots and lots of things. Or t.string literal, create me a string literal node. And because there are so many of these, this API is so big. It's actually really, really nice that there is this Babel types. Babel types. Babel types. Sorry, I was so close. There we go. In the Babel documentation, I'll paste this in the Gitter chat right here. But this is all of the types. So it doesn't have like is or assert or whatever, but it has like how you create these things as like examples. And so here we can see, let's see, t.variable declaration. It accepts a kind and an array of declarations. So yeah, this is really, really valuable. I pretty much recommend you just always keep this open while you're developing Babel plugins. One other handy thing that you can do is Babel also has the ability to create a node based off of a template. and I'll show you that a little bit later. But if like you're creating a complex node that has like lots of other child nodes or something like that, then it can often be useful to make a template, and then Babel will create a node for you based on that template. You pass it data to replace things. And it's kind of magical and awesome. So yeah, let's just look at this one really quick. We have a regexp literal, and instead of receiving a node, you actually receive a path. So like I said, Babel is quite a bit more powerful than ESLint in many ways. ESLint gives you a node and it gives you context, and you can use that combination of that node and context to get most of everything that you need, like 99% of what you need for ESLint rules. Babel is a little bit more powerful because it needs to be. It needs to be able to not only inspect the AST, but also make modifications to it. And so it has a lot more utilities. And if we look at this path, we'll see that it has a node property, and that is the actual node that you get from ESLint. So then you can go through the node. But the path has a bunch of things on it that are also quite useful. Like it has scope. And scope allows you to say, hey, like this variable major is inside of this function, which you can barely see, but it's a major variable declaration, and I can get all of the variables that are in scope with that major variable declaration. So one of the things you can get are all the bindings in that scope, so all the variables that are within that scope. You can also get references to this variable, so I'm not sure which one this is. This is the regexp literal, so there's not like references to that regexp literal. You'd get references on like a variable identifier or something, but you can get all the references in the program to that identifier, and that can be really useful. So one thing to note about this is that Babel is creating some of these things as it traverses the tree. So if you're starting at like the very top and you say, hey, get me all the references to this identifier, then you're not going to get anything because it hasn't gone through the whole tree to build up that scope. And so, and we'll explore this later, but you will sometimes want to just say, okay, this is an identifier that I'm interested in. Let's store that for later. And then when the program is all done traversing and everything, then I can go look at the scope of this thing and make modifications to it and stuff. So anyway, couple of tips there. This is the path. So there's a parent path property, and so you can kind of go up the tree. And then there's a parent, and that would actually be the parent node of the current node that this path represents. A bunch of things on here, and paths also have a ton of things that you can do on them as well. It looks like some of these actually have the utilities that you get from types, which I just barely learned about just now. It's interesting. But like, there's even a hoist function, which I probably should be using right here in this plugin. Yeah, something to learn about. So the Babel API is immense and massive, and so it's dangerous to go alone. There is the Babel handbook. And I'll paste the English version in here. It's translated into a bunch of different languages. But this will give you a really good overview of how to do common things like inserting new nodes or removing nodes or replacing nodes in the AST. Yeah, it's a great thing, also by my man, the James Kyle. Okay, cool. So that's the path. Oh, yeah. If you go, do you have the workshop open? So if you have the workshop open, there is a chat on Gitter badge that you can pop that open, get all the links. Okay, cool. So I'll just run through the code of this plugin really quick. And then I think we'll probably take a break before I start demo stuff and exercise. So the in this case we have this path, and we want to make sure for our regex literals, we want to make sure that these are being assigned to something. So ours isn't super valuable or super powerful where I could just take care of this one. I don't like create a new variable out of this and whatever. I actually only take those that have been assigned to variables. So that's what this is doing. If the path key is not init, so in this case, init is that regexp literal. So if it's not an initialization, then I'm not gonna manipulate it. I'm not gonna do anything with it. Otherwise, I'm gonna go ahead and say, hey path, find me a parent. Oh, this should probably be like parent path. Just be a little bit more clear. Find me the parent that is the program. So go all the way up and give me back the program. And so then I can get the program because that's where I want to insert my new variable. See, I'm taking it from this function all the way to the top level. So that's why I'm looking for the program. And then I get a couple properties off of this path. So I want to find the parent identifier because the parent is going to be this. Let's push this down. So here we're at this regexp literal. I say, get me the parent and get me the identifier from that parent. And on that identifier, I just want the name. Just want to know what it's called. And then also on the parent path, I want to get that parent path. So here we're starting again at the regexp literal. I'm going to get the path that represents this variable declarator, but then I'm going to get the path from that parent or that parent's path. Parent. Yeah, going to go one more level up to get the variable declaration. So I can get that node, so I can get the kind. And in this case, the kind is const. So I want to reuse the same kind. I'm going to create a brand new variable that has the same name, or that's based on the same name, and has the same declaration kind. So it could be const, it could be let, it could be var. I don't care what it is. I just want to use the same one that that the author of the code wrote it in. So I'm pulling all those properties off of path, and then I'm going to create a new identifier. So I'm going to take the program and get the scope off of the program, and the scope has a handy-dandy function called generate UID identifier, and I'm going to base it on the name. So I can actually pass nothing. If I pass nothing, it'll create one for me, just out of the ether. But if I provided a name, then it gives me something that's contextual, so it's worth the effort, I think. So, yeah, we want it to be based off this version regex. So it creates a new identifier. If I already had something like const underscore version regex equals I, then it's actually going to create version regex 2. So that's why this scope thing is so awesome, is because it can generate a unique one for me. Pretty awesome. I'm actually curious. Yeah, it still even gets that, even if I put it further down. So that's pretty cool. Cool. And then I'm going to rename. So based on the program scope, I'm going to say, hey, rename the original name. So this version regex, I want to rename it to this new name that you just created, this new identifier. So at this point, all that I've done is that. So far, okay. But then I'm going to get the programs node, and in its body, so here let's go up to the program node. Program node, I'm going to get the body, and I'm going to unshift, so I'm going to put something on the first item in that node, a new variable declaration that I create using this Babel types thing. So variable declaration, the kind, so the type is going to be a const in our case. But it's coming from the original variable declaration. And then as part of the variable declaration API, when you create a new one, it has to have declarators. Or it doesn't have to, but for const it does. And that's going to be an array of variable declarators. So I'm going to create a variable declarator. And that requires an identifier for the left side of the assignment and a node, an expression for the right side. And so for our case, we're just taking this original variable declarator this regex literal that we had before. And then we're going to remove the variable declarator that this regexp literal was declared with. Does that all make sense? It's super fun. Writing these things is like, I love writing Babel plugins, ESLint plugins. I love working with ASTs. I think it's super fun. Especially when you get it right and it's like, oh, that code just totally moved just like I wanted it to. It's so amazing. Yeah, the huge plugin that I'm currently writing is called Slice.js, and its job is to remove code in a safe way, in a way that the code doesn't totally break, and that's really, really hard to do. So that's a fun challenge. Cool. So that is both Babel plugins and ESLint plugins, just the basic idea. This one, I'll just show you briefly. This is actually kind of a fun one that we will actually write at the end. Like a full-fledged, we could probably publish this and it could be useful to people. But like I've seen a lot of code and written a lot of code like this, where I'll say import file system module. I just want to get the read file function off of it or something. So this actually will probably be impossible to do when ES modules hit node, because it's not technically feasible to infer all of the exports off of a common JS module statically, like you have to with ES modules. Yeah, not for all cases anyway. And so because of that, this pattern won't be possible. What you'll have to do is you'll have to import fs from fs and then use fs read file. Or you could do like import all the things and then destructure it, so read file from fs. So that's a runtime thing, and so that's totally okay. But because this is static, you can't do that. So that's kind of too bad, because there's tons and tons of code in the world that does this. And so this is a great use case for a code mod, where you'd say, okay, find me all of the node modules, or what we're going to write actually is going to inspect the node modules, or inspect the actual module and determine if it's exporting using CommonJS or ES modules. And so it'll work regardless of whether it's like a core module or if it's some third-party module, which is super cool. And so based off of that, then we will transform it so that it works as is, and you can just run this across your code base, and it's a miracle. It's amazing. It's awesome. And so what I'm not actually going to run through this because we're going to do it later. But yeah, you're taking import declarations and you're checking import specifiers, and basically what the result of that is, just the valid code that you need for your code base. And then you run this as like a one-time transformation across your code base. You commit that, push it, and then you don't worry about the Babel plugin. So whereas like most Babel plugins today, you have it run as part of your Babel pipeline. Questions? Titus, you look like mind blown. Yeah, so much better than find and replace. Good luck find and replace with some of this stuff. Like I've got in our example, I've got const resolve equals blah, and now we have this resolve, and you don't want to change this one, but you want to change this one. Yeah, have fun with find and replace on that. No, but Babel can totally do this and not mess everything up. ASTs, man, so cool.
So like somebody should totally write a plugin or like code or Atom or whatever that has basically like advanced tools for refactoring.
Oh, that would be sweet.
Into the editor.
So like right in the editor, instead of find and replace, you say like, I'm going to write this Babel plugin find and replace, and it'll just run it in your editor.
Yeah, like it'll read your Babel RC file and it'll like know all the things. You just put that thing in there, and you can just say rename, and it'll actually, because right now I think they all just do basic find and replace type stuff.
There's one plugin for Atom that uses ASTs to rename. Yeah, it's pretty wild, but like, that would be super cool. Well, actually, I think WebStorm probably has something where it's like, hey, I'm changing the signature of this function. I'm swapping this variable, parameter to this like order or something like that, or like taking it and destructuring rather than passing in arguments, and just structure an object or something. So you could like write a quick little Babel plugin to do that. That'd be so cool.
Yeah, because up until this point, I've never seen an editor for JavaScript that has been able to successfully do this 100% of the time. With like C++ or C#, like Visual Studio is 100% guaranteed to work in factory. But I feel like with the JavaScript one, it's like maybe 80% of the time that'll work, and then the other 20% of the time you run it and something breaks because it doesn't understand like all the weird ES6 stuff.
Yeah, JavaScript is just really hard too because it's not typed, and so yeah, makes it harder to do refactorings because of that. Cool. So that's that. I have tons of resources, by the way, on this slide deck. So if you wanted to check those out, those are handy. I'll just paste another link there to the resources. And that's the talk portion of this. Now we're actually going to start. Like that's my last slide. We're actually going to start getting into writing stuff. But I think we should probably take a break. Then we'll come back. I'll do a demo, and then you'll get to do an exercise. The demo is pretty small, and the exercise is fairly small too. And we should be able to do both of those before we go to lunch. And yeah, so let's take like a 5 or 10 minute break. Okay, neat. So yeah, so that's it for slides. I'll just close that, and we'll go to the project. So, quick little demo. We're using package scripts in here. I know that Denver knows a little bit about package scripts, but package scripts is actually, it's called NPS, and it is like NPM scripts that are really, really powerful. And so our NPM scripts are actually really simple here. We pretty much just have a start that calls the NPS binary. And what that allows you to do is you say npm start, and then you can use nps, and one of the commands for nps is help. So npm start help will say nps help, and it'll output the help for nps. And one of the things that nps will give you is the available scripts that you can run. And it gives you the name of the script and a description. And so for you, mostly what you care about is test, and maybe test changed, but probably test watch is what you'll mostly be focusing on. And so when you're doing your exercises, that's what you'll run, and then you can, I can show you a little bit more about that later. This is kind of sneaky though, because we've got more scripts than that, but I've hidden them from the help so that it doesn't distract you from what you're supposed to be doing. So one of the scripts that I'm going to be running is nps. Oh, and I have nps installed globally, so I can just use nps. But yeah, you'll use npm start most of the time, or yarn start. And then the rest is the same. So I'll say nps test demo watch. Nope, maybe it's demo test watch. I can't remember. Test demo start. There we go. Demo start. Test demo start. There we go. Okay. Cool. Now with that, I can go to our first demo. And we have totally blank files. What we're going to do is, actually, we won't even start in this, in the project. We'll start in AST Explorer. And then we'll copy it over later. So what we're going to do here, to start with completely blank files, is we have the Esprit parser. We're transforming it with ESLint version 3. And we want to disallow the use of alert. So this plugin actually already exists, but we're going to write it. So we'd say alert hi. We'll start it with that simple use case. So if you have an identifier that is a call expression, or an identifier called alert, that is a call expression, then we will say, hey, ESLint, we don't like this, don't do this. So anybody remember how we start out defining our ESLint plugin?
Are we going to do actually?
We'll start it in AST Explorer, and then I'll copy it over to the demo. Yeah, module exports. Yeah, with create, that takes a context. That's right. Turns another object. Perfect. Yep, exactly. So this is a minimal ESLint plugin. Does absolutely nothing, but this is everything that's required for an ESLint plugin. Okay, so then we inspect our example code and look for the pattern, or like a pattern in the AST that we want to look for. For us, we could either do look for identifiers and see if they're called alert and if they're part of a call expression, or we could just look for call expressions. I think in the solution I use identifier, but call expression is probably a little better because if you're thinking, like, you normally don't want to think too much about performance, but like if one is just as easy as the other, may as well do the faster one. And there are probably fewer call expressions in our code than identifiers. So identifiers are everywhere. So we'll start with a call expression. And what do these visitors accept in ESLint? So these are functions. Yeah, you're right. Okay, take a node. Good job. So let's go ahead and console log this node. We'll inspect some stuff about it. So this node is a call expression, naturally, because that's what we're looking for. And it has a parent, it has a callee, it has arguments. So let's go ahead and say, like, we only want call expressions that have a callee with the name alert. So we'll say if node.callee.name, so here name equals alert. And actually, normally I like to exit if it's not what I'm looking for. So then the rest of my code can be more flat. So if it is what I'm looking for, then I can say context.report, and I report on the node. And that's actually all you need for a report is just the node. But I'm also going to add a message, no alert, please. And can I get that? Yeah, very, very minimal ESLint plugin. Now, this naturally will not work very well for all cases. Well, yeah, it looks like it works okay for that. Yeah, so it's not going to get alert.call. Wait, yeah, call is the non-array form. Or apply. So we could go on forever. We could also do window.alert, okay, and then we could also do the call and apply version for window.alert. So, but like that's the right way to think about it. Is you think, okay, violations and non-violations, and you just come up with a ton of examples. Yeah, you could even like go really crazy and then the nice thing about this is, like, even with this minimal example, it starts providing us value right away. And then we can slowly add more to it and get more value out of it. And so, yeah, but yeah, I think it's pretty neat. So we could do more with this, but I'm going to go ahead and leave it as is. But like one kind of useful thing that I sometimes find is making like stateless functions that will say like this is the thing that I'm looking for. So I say is alert call, take the node, and then I'd return if it is the thing that I'm looking for. And then I just say if not is alert call node. And so then in this I could say, okay, if the callee name is alert, or if the node.parent.whatever, yada yada yada. And you just do like a ton of different cases where this thing could match. So that's our basic ESLint plugin. So let's go ahead and plug our plugin into our code. So we'll go into our ESLint demo test now, and we'll write out our test. So ESLint provides a really great way to test our stuff. So we'll import their rule tester from ESLint. And we'll import our rule from 201 ESLint demo. And like I said, you'll have an exercise, and so if I'm going too fast, I'm sorry, but I'm not going to wait for you to follow along. You'll get an exercise, and we can work on that together later. Okay, so we're going to create an instance of a rule tester. New rule tester. And then with that rule tester instance, we're going to say run, and then we give our rule a name, and that's mostly just for the test output. So we'll call this no alert. And then we pass the rule, and then that. And this object is our test cases. So we have valid test cases, so code that will not fire off this rule, and invalid test cases, so code that will fire off this rule, and what the error looks like that it fires. So for some valid test cases, we have one right here. Just put that right there. And actually, normally I do template literals. And here, what's another valid test case? Just the key or the word alert. That's not like we're not calling it, so that's fine. Or window.alert. That's fine too, just so long as you're not calling it. And so we'll save that. We'll get these things run, and we see those tests are passing. Hooray! So let's take a look at some invalid cases. So for the invalid side of things, instead of just regular strings, you're going to want objects. And these objects are going to have a code property and an errors array. And then the errors are an object that describes the type of error that's being thrown. So let's see an example here really quick. We'll say alert. Hey, that's pretty much the only thing that our code is ready to violate on or to report anyway, so we're good there. So in our case, we're getting, and actually, fun fact, we're using an alpha version of Jest, the testing framework, because the alpha version just added so much better support for the assert module, which the rule tester is using. So yeah, before, like if you're using an older version of Jest, like version 19.0.x, then you won't be seeing this output. It will not be nearly as helpful. So anyway, our assertion error is, like we don't have any errors in this array, but we should have at least one, and it should look something like this. So we don't have to have all these things, but we do need to have at least the message and the node type. Or actually, I'm not even sure we need that stuff. I think if we just have an object, that's enough. So we can be as specific or as non-specific as we want. I normally see people use type. So this is the node type that is being reported on. So that node type is a call expression. And then the message. And sometimes the message is like constructed, that like your message could say something like, it needs to, or this alert should actually be, you know, foobar or something like that, based off of the source code. So sometimes that the message can be a little bit like it's not just a simple string, but most of the time it's fine. In our case, it's just no alert, please, and we got it. So if we change this to have a typo, then we're going to get this handy dandy output. Yeah, there's still a bug in the alpha version, but it's still better than nothing. So we see the difference here. We misspelled it. That's fine. We can just change that to please. And then from here, we can iterate and add more test cases and make sure we're covering more things. I've seen some rules that have like hundreds of test cases. And And that's great. And anytime somebody wants, like, I love this abstraction, this testing abstraction, because it's so easy to say, hey, I've got a bug with your thing because, like, I write my code in this certain way, but you're reporting that it's wrong, so let me add a valid case, and then we can figure out how to solve that. Or, hey, it's not reporting this code that I wrote that should have been reported or something, and then you just add an invalid case, and then you can fix the stuff. So, pretty great. And that's it for the demo. Now it's time for exercise number 1. And I filled out a couple things for you. Maybe I shouldn't have, so that you could have read them yourself. But the way that this is going to work is, oh shoot, I forgot what you were supposed to write. Oh yeah, disallow use of console. So like console log, console info, console anything, I don't want to see console in my code base. And so you can fill out the metadata if you like, give it like a description, disallow use of console. A category would probably be like best practices or something, and whether or not it's recommended. Some of this stuff is like kind of config and plugin specific stuff, so you can go look up what this stuff is later. But yeah, you can say whether or not you recommend people use this rule, and then whether or not it's fixable. And we're not going to be doing a fixer right now, so you can just leave that as it is or remove it entirely. Yeah, and then from here you just return your visitor, and then you need to write some tests for your no console. And that is that. Probably we'll go to like noon, or not. You probably won't need that quite that long. We'll go to like 11:40 or something like that. Give 20 minutes, and then I'll work through the solution with you, and then we'll go to lunch. Yeah. So there are actually like even in this workshop, I've got some abstractions for some of the tests. So like I have this valid function I call or invalid function I call that will return me objects that have like the options that I want for those cases. And so I have seen like most of the time your code, like your valid or invalid, can be verified with just 2 or 3 lines of code or less, sometimes even 1. Because yeah, ESLint rules normally don't require like a whole file to know whether or not you're in violation. So I haven't really seen too many that like abstract away the construction of the code example itself. But you could totally do that with like a template rule or something. And again, you should probably be working on these exercises in AST Explorer until like you're ready to actually write some tests and stuff. Once you do, it's let's see, what you'll probably be typing is npm start test.watch. As a fun pro tip, you can alias or prefix things, so t.w will work as well. Test.watch, t.w. And then it will start out by not running any tests until you make changes to your file. And then it'll say, oh, you changed this file, so I'll run those tests. Just as amazing. Yeah, you can do all kinds of really amazing things. So I recommend actually reading the output in watch mode because it's pretty cool stuff you can do. But yeah, right now, mostly the AST Explorer is the place.
And the docs for like the is-alert call, I'm sorry, not for
Oh yeah, so the Babel types thing that I was talking about, that's just for Babel. But the like AST node types and stuff will probably be in there. You don't normally need those though because you can see it right in the AST Explorer.
Okay.
Anyway. As a tip though, I use console log all the time. So I'll console log context, and I'll pop open my console and I'll look at what's available on context as well as the prototype. So I can see, okay, what are these things? And then you can go look up in the docs and see what they actually do. In AST Explorer, you'll be using Esprit. That's ESLint's default parser. for the transform, you'll use ESLint v3. You could also use Babel ESLint for your parser. That would work just as well. Babel ESLint will handle more syntax as well. And we'll see a little bit later how to make it so your tests, like in the project, actually use Babel ESLint, because like when we start doing import and export and stuff. Well, actually, ESLint can support that with certain configuration, but there are other things that it's just nice to have. Well, I take that back. Babel ESLint is only really useful for certain stage features. Many features ESLint actually supports out of the box, just with the right configuration. Yeah.
If there's a context about report, it won't should I make sure that it doesn't fall through, like if I have 3 different reports?
Oh, you don't want to, yeah, it'll report on all 3, or do all 3. Yep. Try to make your rule as simple as possible at first. You want to err on the side of not reporting something than reporting like too much. And so start out reporting like the most basic thing you can think of, and then iterate to make your rule a little bit better. I'm going to start working on the solution in about 5 minutes. So I'll go ahead and start it up. If you're not quite finished, that's fine. You can finish another time during lunch or something. Okay. So let's go ahead and I'll just reuse the same stuff that I have here. We'll just take us back down to the regular visitor. Okay. So a couple examples that I want to go against. Hey, and dot info hi. And then I'll say that console is fine, and console dot like info is fine. Okay. So let's just inspect these really quick, see what is bad about these things or unique about these things. So it looks like for both of these, they are member expressions that are call expressions. This one is also a member expression. So I think in my actual solution, I just said member expression. So I would warn on this, or yeah, throw an error on that. I'm not going to do that this time. Maybe I'll fix my my example later. I'm going to do call expressions. So call expressions where the callee is a member expression and the object is console, or the object identifier is console. So start with call expression. And again, like we could start at any point. We could do a member expression. We could do an even identifier. I normally like to start at the top node and then work my way down, because there will generally be fewer of the top nodes than the leaf nodes. And that's only one reason. It's also easier to kind of inspect that node from its children. Sometimes that's not the case though. Sometimes it is easier to start from somewhere in the middle or something. Okay, but I'm looking for call expressions. I'm going to take the node and I'll say if it's not is console call, then I will return. That's right, is console call down here. Takes the node, and here I'll return the node dot callee is equal to, or sorry, dot type is a member expression, and here, and actually one other thing that you really don't want to do is have your ESLint rule throw an error or something, blow everything up. And that's actually especially important for like code mods and Babel plugins, because I'm pretty sure ESLint will just be like, okay, and it'll just move on. I think, I'm not sure. We could find out. Yeah, we'll find out later. But yeah, it's often kind of nice to just like double check things. So there is a node and it has a callee. You could probably write a little abstraction around this to say does this node have this sort of shape? I was actually thinking about finding something that would do that because that's kind of often what you're doing anyway, is just seeing whether a node has a particular shape. That's what we're doing. We're saying the node has a callee and its callee type is member expression, and the node dot callee dot object dot name is console. Okay, cool. We'll just go with that for right now. So then if we console log the node, you can see we get 2 that pass through that if statement. And I think those are probably the 2 that we're looking for. So we'll keep going. We'll say context.report on that node with the message bad console or something more useful. But yeah, there we have 2 reports for bad console. And if I were to invoke this, then that would change this to being reported as well. This is also going to report on console.foo. And so like, I don't mind warning on that because you probably shouldn't be calling console.foo anyway. So I'm going to leave that as it is. So we're pretty much just saying, are we calling something on the console object? That's what we're warning against. We could make it more robust, but we'll just leave it that way for now. We'll go to our ESLint rule here. I'm just going to take the create function from the create function all the way down. I think I missed a couple of curly braces here. This is why I love Prettier. Watch this. Save. Oh, snap. Dang it. My demo was ruined. Oh, wait. Save. Boom. Fix my turn or my, well, that thing. Yeah, so cool. I love it. Okay, so great. We have that. We could say disallow console for our description category, best practice, quote, I guess. Recommended, we'll say it's true, yeah. We're going to comment out fixable right now and schema because I'm not going to add any options. We're actually not going to be doing options for our rules today. You can go look at schema later. But yeah, so we have this. Let's go ahead and look at our tests. I have one failing test, and that's the elaboration feedback. So go here, copy that, paste it in your browser, fill out that feedback, set this to true. Okay, so we have passing test. But now let's write, we'll copy over some of our valid cases. So just using console here, like that. So those 2 should pass, great. And we'll take some of our invalid cases and we'll turn those into objects where the code is right there. And we'll duplicate that. Oops. You know what? It's so cool. I was about to format this myself, but yeah, I'm no monkey. Boom. Yeah, I love you, Prettier. Okay, but here we're getting failures because did not specify errors for invalid test. If no console, you need to have errors specified. So we'll say errors is an array, and we only have one error, and the error will take the node type. It's going to be call expression, and the and like it's kind of up to you how specific you want to be about the types of errors. Like for us, all of the node types are going to be call expression, and we don't really need to test for that. For some, though, you will be reporting on specific nodes, and they could be different types and stuff, and so sometimes the type is useful to include in here. For us, I'll just go ahead and say message, and our message is going to be bad console. But yeah. If you don't even care about that, you just leave an empty object. Say there is an error. I would probably not do that. Having the message at least is kind of nice. So then we'll put errors there, and poof. And we'll just make sure that it can fail. Yep, it can, so we're good. Yeah, that's great. Okay, any questions about that? Okay, cool. Let's do lunch, and I think probably do like is an hour enough, or should we do an hour and a half? Yeah, for lunch.
I'll be out for one.
Oh, okay.
Well,
Oh, okay. Good for you. Spring time. All right, let's be back here at 1:30. Do just over an hour and a half for lunch, and yeah, we're going to be doing ESLint plugins some more right when we get back from lunch. So yeah, I think you'll be okay. Okay, cool. We'll see you all after lunch. I'm going to pause the broadcast. I'll stop the broadcast, and I'll start it up again later. Bye. Yeah, we finished off with the first exercise of reporting on the console. And the next thing, so I probably should have given like a more holistic view of things. I kind of talked about it at the beginning, but we've got a demo for 4 ESLint plugins, 2 Babel plugins, and 2 code mods. And then we have exercises for each of those as well. I think we might skip an ESLint plugin or two in the interest of getting to the Babel stuff. But yeah, we'll definitely do at least another one. Let's see. So for let me just actually look at this really quick. This one has a fixer. This one also has a fixer. Yeah, I think we're gonna go ahead and skip to this one. This one's actually gonna be quite more involved. Yeah, so I'll be going through demo number 4, and feel free to follow along if you want to, but I'm gonna just be working through it. So actually, let me do this. Demo number. Okay, and that's the solution we want. Start. 4. Okay, so we actually already have some test cases here that we can reference. So what the use case that we're talking about in this one is we have an API that we use, and it's called Bucket Streams API. Bucket Streams is an app that I built that was supposed to kill Facebook. And I still think that it is better in concept, but it never quite made it in reality. Yeah, so the Bucket Streams module, it used to have this request function that you could call on it, but now that API has either been deprecated, or maybe we prefer to do things a little differently for one reason or another. So instead of this request with a method of get, we're going to encourage that people use this just the get function on it with the URL and then the object or the data. Okay, so yeah, so that's basically what we're going for here. And hold on, I thought that. Oh shoot, no, this doesn't have a fixer function. Rats. Yeah, let's do this. Let's do this one right now, and then we'll do a fixer function in the next one. So we'll go a little bit out of order, because I think fixer, it's a good thing to learn. Yeah, and this one would actually be kind of hard to auto-fix with ESLint, because ESLint more works with tokens and strings and stuff rather than actual nodes, and so it would be a little hard to auto-fix this one. But yeah, so let's go ahead and we'll start writing this. So we've got our valid use cases here. Unfortunately, right now in AST Explorer with the ESLint plugin, if you try to use import, it's going to give you an error that says it only appears in the source type module. Despite the fact that I have source type as module here in the parser, there's actually another parser for the transform, and that one you don't have control over the options as of yet, and so that's why we're getting that error. So we're going to build the require version first, and then like in AST Explorer, and most of that will be the same, and so we'll build the import side in our project. So here we have the require here, and we'll pull in an invalid example as well. And we'll do another invalid example. I'm not sure what's different about those two. I guess it's just import. Oh, okay. Yeah. Okay, anyway. So here's our valid and invalid. Great. And let me just pull in. Sorry, did you have a question?
Oh, sorry. Yeah. So the ones that I see that are valid, all imports.
Yeah. So there's one valid one that has a require statement. Are you sure you're looking at because the exercise is really similar to the demo.
Oh.
So you might be looking at the exercise.
Yeah.
Yeah. No, you're good. Okay, cool. So let's just look at the AST that we're going to be inspecting and see like how can we determine whether or not this is the right require and whether or not that variable is being used in the right way. So first, we need to find the variable that is being used. And then remember that ESLint is going to be calling our visitor as it traverses the tree. So when we find this require statement and then we're going to determine, okay, that require statement is actually what we need to, or that variable is what we need to track and find how it's being used. So we may get the variable, but we don't know where it's being used or how it's being used until the whole thing has been parsed. Or sorry, until the whole thing's been traversed. So what we're going to do is first we'll get all the instances of where we're requiring the bucket stream API, and we'll store a reference to every identifier that's being assigned to. And then we'll when the program or when the traversal has reached program exit, so when it's just finished, then we'll go through all of those identifiers that we stored up, find all of the bindings that were traversed through, and then do our checking. Does that make sense? Why we're doing that? So when maybe it'll make more sense when we actually start writing the code. In fact, I think that it will very much make more sense. So let's just continue on, and hopefully it's more helpful. So this here is a call expression to require. We might, we could do it a couple different ways. I'm going to go ahead and do a variable declarator here because we're declaring this variable BSA equal to that require statement. So I'm going to use variable declarator, and that'll accept a node. And oh, whoops, sorry, this create needs to return our visitor. And then I'm going to add a function down here that is require bucket, or BSA, bucket streams API, Boy Scouts of America. That'll take our node, and first, because this is a variable declarator, let's take a look at that variable declarator. It has an identifier. We don't really care what that identifier is for our use case, but we want the init to be a call expression. So we'll say return the node.init. Type is a call expression. And then we want the callee to be require. And node.init.callee.name is require. And then we want the arguments. There should only be one argument, and the argument should be bucket streams API as a string. And so that'll be, let's see, node.init dot arguments 0 dot value. And node.init dot arguments 0 dot value is bucket streams API. So pretty wild and nutso. This is a great opportunity for me to go over here and show off how much I look prettier. Yeah, you're good. Thanks. And so now let's go ahead and run this on our node, and we'll say if it's not a BSA required, then we'll return. Otherwise, we'll console.log the node. And we should get 1 there as the variable declared. So we are good so far. Okay, so now let's go ahead and let me show you a little trick with the context. So the context stores pretty much everything that we had about scope and things from Babel. It encapsulates that same kind of functionality. And so we're going to say console.log context get declared variables for that node. Let's see. Hold on. Yeah. And whoops. And that's going to be an array with the first item being A, and that this gives us a declared variables array, which I'm not sure, that's not really a node type, it's just like its own kind of data type, but it has scope and it has references. And yeah, here's the really tricky part. So let's keep going, because if you look at this, it's like, okay, I look at references. There are 3 references. There's the one itself, and then there are 2 other references. So that's great. But this is actually a little bit tricky. So we'll get that first item. Now I'm going to actually leave this console open. And each of these items have that references array. References. So we get 3 items. And then references at 0. Hold on, blank. Now that is the strangest thing I ever did see. Yeah, this is weird. So I was going to say that the Chrome DevTools was fooling us, but it looks like it's not. It looks like we actually do have all 3 of the references at this point in time, which is great because doing this program exit thing was not cool. I'll show you that later at the end in case you ever run it against something like this, but it looks like we can just go ahead and iterate through these references right now, which is cool. Okay, so we have the references. The first reference is going to be ours, like the current one, the variable declarator. Well, actually, we don't know that for sure, so we're going to filter out ours. So we'll say references equals that dot filter reference. And here I'm going to console.log the reference. And so how we know whether this reference is our reference is by looking at the identifier. And that identifier should be the same one that our node identifier is. So if we look at our variable declarator, it has an ID. And our variable declarator is the node that we're visiting right now. So we can just return reference.identifier is equal to node.id. Does that make sense?
Yeah.
And then here, let's just, oops. Oh, and actually, sorry, we want all of them that are not this one. So it's going to be reference.identifier is not equal to the node.id. And then we have all the references that are not this one. I guess it doesn't actually really matter because when we go and inspect all of the references, we're going to see, am I calling request on this reference?
Yeah.
And in this case, we're not. So it probably doesn't really matter that we filter it out at all. So yeah, that's a good, interesting point. Okay, so now we need to take these references and iterate over them to find the ones that are using the API incorrectly. And so actually, if like normally you just say, array.forEach. Yeah, and that is an array, sorry. This is kind of like throwing me off because this is totally different than what I created in the first place. Because yeah, what I used before was I created a weak map, or no, not a weak map, but a set to store all of these, and then when the program exited, I iterated over that. But we don't need to do that. So
the reason we're getting this is because we're getting all the variable declarators, which is those two.
It's really just one, yeah, just when we declare that variable.
Mm-hmm. Yeah. So you get that, but then when you context now that BSA thing, get the variable
for that BSA thing.
Right, for that BSA thing. Why? So I'm trying to figure out why is it showing 30? Oh no, it's the first one, one, and then you get the references of that, which is all the places that, which is because it's the variable BSA.get and BSA.request. Is that why we get?
Yeah. So these are all the references for the. Oh shoot! You know what? Sorry, I'm leading you astray. So
okay.
What this get declared variables is going to do is I give it a node, and it based on the scope of that node, it gives me back all the variables that are in scope of that node. And so by pulling off this first item, we're actually just lucky because there is only one declared variable. If we declared another one, const foo equals var, then I would expect that we would get a
0 would be that one instead.
Yeah, I would expect so. Now I'm like confusing myself. This is why we practice. Oh no, that's right. Here, let me. You'll have to pardon my apparent lack of preparation here. Well, let me just go look at the docs for context really quick. Get the working with rules. Get declared variables. Returns the declared variables on the given node. Yeah, that doesn't really. That's not super helpful to me. So I could get the scope, which is what I kind of thought. Okay, well we'll just run with it. It looks like it's getting this all the instances of this variable. Just like not at all what I would expect it to do. So what if we did? Oh wait, no. Here, let's go ahead and console log up here as well. So we'll say node.id.name. Okay, so for foo, the declared variables for this. Oh, that's weird. I wonder, what if we did this? Var, and then BSA equals hi. No, it's still not returning any more than one. I'm not sure why this is, why it's giving me back an array, get declared variables.
Yeah.
But I guess it always just returns an array of one item, and that's why we're safe to go with the 0. These are probably things that I learned as I was making these demos in the first place, and now I've forgotten. So it's good to be reminded. Apologies for that. Okay. Cool. So we are set. We are safe. I'm going to leave that foo there for now. And now we have all these references that are using the BSA variable, and now we're going to go look at them and see how they're using it and if they're using it okay. So if we look at one of these, we can see it has an identifier. So each reference has the identifier that is referencing our variable. And this identifier has a parent that we can go look at and see how this identifier is being used. And in our first case here, the parent is a member expression. That's the kind of thing that we're looking for. We want to see when it's actually being used to make a call or something like that. If we look at the member expression parent, that'll be a call expression. So there are a couple of things that we could do to verify that this is actually we're getting something off of this BSA variable, and we're making a function call off of it. But for us, we'll just go ahead and make it simple for now. We can solidify it later and say, okay, if the identifier has a parent that has a property with the name of get, then that is valid. Or rather, if it has a property with the name of request, that is invalid. Okay. So we're looking for all those uses of the request function on the BSA variable. So let's go ahead and take our references, and we'll say for each. For each function, we'll get a reference, and we'll say if ref.identifier.parent, so now we're on the member expression, .property.name equal to request. Or here we could do not equal to and then iterating. We return. Otherwise, we'll console log ref. And we're getting not read property of undefined. Whoops. Console log ref.identifier. Right. Oh, here we go. Haha! So I've got to think of a way to explain this. Maybe we should just run into this problem.
Okay.
I'm just trying to think of the next time I do this workshop. We run into the problem, and then I explain why this problem exists. And then, yeah, so it's not that it doesn't have all the use or all the references. It's just that those references, the nodes for those references haven't been fleshed out.
So we're like in the first pass.
Yes. Yeah. So there we go. That makes me feel a little bit better.
So this goes back to like earlier.
Yeah. This is the problem with the fact that the whole AST hasn't been traversed yet. So we are going to make that set. So we'll say const identifiers. So we won't store the references. We'll just store the identifiers they're referencing. A new set. I'm glad. This makes me feel so much better. I was like, I did something so wrong or something. And instead of this filter thing up here, we'll just do a for each. And we'll get rid of all this stuff right here. And yeah, so for each of these references, we'll say if it's not the my current identifier that I'm looking for, then I'm going to say identifiers.add my reference.identifiers or identifier. I'm just going to copy all this, paste it in here, format it, and copy it back. There we go.
Oh, I added it so much.
Yeah, you added prettier or something? Yeah, or prettier. Yeah, good stuff, man. It is so nice. Okay, so great. So now we need to be able to figure out some way to hook into when ESLint is about ready to be done traversing the tree. So when it's done traversing the program node is when it's done traversing the tree. So it exposes a special visitor type API that's different from Babel. Babel does things a little bit differently. But the way that you do it is you say, like normally you'd say program when you want to start visiting the program node. The way that you do it when you want to have it call your function when it's done with the program node is :exit. And so you'll need to wrap that in quotes.
Sorry, could you say that one more time?
So the property on your visitor object is going to be the node type :exit.
Oh,
And in a string. Yeah, and it's a special thing that it says, okay, I'll call your visitor when I've exited or when I'm exiting visiting this node. And because it's the program, that's the last node, so we know that it's not going to traverse any further anywhere else. So that's going to give us the node. I don't think we actually need the node though, because we're just dealing with the identifiers. We already have the identifiers. We just need to know when we are exiting, so we can safely do stuff with the identifiers. So now we want to iterate over the identifiers. Because it's a set, we could do this a couple ways. We could do like a for of or whatever, but I like array methods. So we're going to turn this into an array with array.from identifiers. And for each of these, we're going to get an identifier. And we will iterate, or we'll take that and say if the identifier dot parent dot property dot name. So the identifier, we're going to get the member expression parent that has a property, and that property's name is, or if it's not equal to, or sorry, no. In this case, it could be equal to get or put or post or delete. So we're going to actually do the case where we're going to look for the invalid case because that's simpler. Request. Actually, no, sorry. All those words I just said were not simpler. So if it's not equal to request, then we can exit everything.
Wait, so, sorry, so so when we get to program exit, we built our set, all the identifiers,
yep.
Which would be, instead of 0, potentially, it'll be 3.
Yeah, so actually, based off of what we experienced, ESLint does have all the identifiers. It's just that the nodes around those identifiers haven't been built out yet.
So we build them out. So if we console, sorry, I'm trying to so we logged out identifier, then it will give us items that have. So the identifiers are. I guess I'm a little confused about all the variable declarators and the identifiers, because the identifiers are for the variable declarators.
Yeah. So yeah, it's kind of a little bit confusing, especially since like this this is considered part of the reference. But what we're doing here is we say, hey, context, give me all the declared variables for this node, which is kind of confusing to me. But basically, it's going to return us an array of one item, and that is this declared variable. We don't really care about that. What we care about is that it has a references property on it, and that references property is an array of references to the identifiers that are using our declared variable.
Okay. So we found. Okay. It's just the API name is constrained, so it actually just gets the variable and says, okay, it's being used.
Yes. Yeah. Well, it's being used in 3 because it's including the declared.
Right. Okay. And then now we add that to the set, all the places that it's being used, and then from there we can target the .get or .get.
Exactly.
That's why you're doing it.
Yeah, exactly. So we can't do it at the time that we get all of the references, because it hasn't traversed the whole tree yet, and so we're going to do it at program exit. So yeah, we just have to store this state, and that's actually a pretty common pattern to store state in some other place. I think that there is, at least in Babel, there's an API where you can store state within some sort of context.
Okay.
And I haven't used that a lot, but I've seen it used. I don't think that there's anything like that for ESLint, so we do that ourselves here. Okay, cool. So yeah, so if we console log here, we're going to see an identifier whose parent has a property that has a name request. And this is a violation of our rule, and so we can report on this. So we can just simply say context.report node with the message no request please, and oh, not node, sorry, the node is going to be identifier parent. Here we could even say dot property, so that it reports right on the thing that we're using. So it is so cool. It is like, it is hard sometimes, but like when you can see your code as just a bunch of objects that you can reference and like poke around with, it's just a lot of fun. And this isn't very robust, like super robust or anything, but it's like we could make it even more robust. So I'll show you my finished example that does a couple more things, and then we'll get into the exercise. So if we do, this is exercise 4. I also handle import statements, and so here we have an import declaration. And imports are a little bit different. We can actually look at imports, even though ESLint can't run on them on here. We can look at what the AST looks like. So import bucket streams from streams API. So then from here we see we have an import declaration, and that has an array of specifiers, and there can be import default specifiers. There are 3 types of specifiers, I think. Well, we can look at that later, actually. We will be looking at that later. But in this case, there is an import default specifier that has a local identifier, and that's the name that it's being referenced by. And so we pick up that name to get the declared variables for this thing. That's what we're doing right here, getting this first specifier. And so in our case, we're saying, well, here, and then another important piece to this puzzle is that the source for our import is bucket streams API. So we don't want to report like whenever we're importing Lodash or something. And so we're saying if the source value is bucket streams API, or sorry, if it's not that, or it's the first specifier is not default specifier, then we know that this isn't something we're interested in, we'll skip past it. Otherwise, we'll get the declared variables for that first specifier, and there should only be one in this case. Nobody's going to be importing default or something. Like, that's just the way that we write code here. Or just like every 15 minutes, wave our hands for that light. Yeah, and then we'll get the variable references and add those identifiers. So from there, it's like very similar. In fact, I'd even like extracted this into a separate method, but I was like, no, we'll just stick with what we've got here. That duplication isn't all that bad. So yeah, and I think in this case, it doesn't actually include the import specifier as one of the declared variables, and so that's why here we're slicing off the first one and here we're not. But in any case, lots of different ways to do the same thing. Because node ID is an identifier, always one item. I know that comment made sense to me when I wrote it, but that is supposed to explain why we're pulling off just the first. I'll have to look into that. later. So in any case, we're handling imports and require statements here. And we do the same thing, except I do a little bit of magic to give us a nicer error message. So the let's see, method name, the method specific API. So basically what all this code is doing is finding out, okay, so you're using request, but the way that you're using it is with this method, this method of get. And so what I'm trying to do with my error here, let's just do this really quick. I'll paste it and you'll see it. So the error message is quite a bit more friendly. The request API has been deprecated, use get. And if I had said post, let's say use post.
Oh, okay.
So that's what all of this code right here in this if statement is doing, is trying to determine, okay, what method are you, should you be using instead? And if I didn't have anything, use this method specific API.
So so you're looking into the arguments list and object, and that object has a method that has post.
Yeah.
And you say post. Otherwise.
Yeah, it's a little bit less specific than post. It just checks if that object has a method with the type being a literal, and then if it in that case, then I'll use that literal value. So, yeah, and then I just have this report helper function that kind of constructs that for me. And report allows you to have a method that is templated. And so here we say method, put method name there, and then we provide some data for that. So that's that.
Yeah, it's very raw, but it's also very expressive. It's both raw, but also by the nature of what it's doing, it's also very abstracted.
Yes, it is very abstracted, and I love the declarative nature of the visitor pattern. Yeah, it's awesome. So, so that is it for our demo. Here, I'm going to just reset everything. For the exercise, it's very similar. Hey there, Bruno. Welcome back. So for the exercise, you just made it in time for a really complicated exercise. Hopefully not. Oh, hold on. Oh, I forgot to rename this test. It should be no old Twitter APIs. So in this case, we are trying to disallow the use of fetch from Twitter. So we have some Twitter module. It has a fetch function, but it's been deprecated, or we don't want to use it. And so we want to use the request instead. And this one, there is a fixer for it, or you can write a fixer for it. And some of these test cases expect one. So don't worry about the fixer. And in fact, if you want to, you can just comment out the output for right now. Yeah, in the exercises. And just get things working without the fixer. And then we can talk about the fixer a little bit later. And I'll fix up this part of the workshop so it's a little more straightforward.
Is the fixer going to be something like rewriting all the fetches?
Yeah.
Version?
Oh yeah. So it really kind of depends on the use case. Yeah. If one if it's just a matter of instead of Twitter request use or instead of Twitter fetch, just use Twitter request. You might be able to find and replace that or write a code mod for it, especially since it's a one-time thing. But the example that we just used with this bucket streams thing, so one nice thing about using an ESLint plugin rather than just a one-time code mod is if the old way still works, it's just discouraged, then people could still continue to use that, use the old module. But if you have an ESLint plugin lying around, then it'll say, hey, this is wrong. don't use it this way. And if you have a fixer, then you can say, hey, you wrote this the wrong way, but I can fix it for you. And then you don't need to worry about it. So there's power in having both the fixer and the just like the ESLint plugin itself. So sorry, I actually accidentally stopped the recording at this point, or soon hereafter, and so you don't get the rest of the afternoon, so like all the Babel stuff and everything. So really sorry about that. I hope that what you have here is helpful, and yeah, definitely check out Friend and Masters to get even more awesome AST magic and stuff. Thanks.